Hi, welcome to the fifth section of this course. Here we are going to learn how we can turn the tricot rankings into a Plackett Luce rankings. This is a very important process in changing turning the data, not changing, but coercing the data to another format in the way that can be analyzed by the Plackett Luce model. I hope that you learned a lot about the Plackett Luce model with the lecture from Heather, and if you have any questions, just let me know. So this will be another show and tell lecture, where I already have the slides available on the course web page here. But most of the work that we are going to do here will be on R, and I just have one small part of this in Excel just to show how the process works. So we focus more on the process rather than the R code itself. So the content of this lecture is to work with the beans data, which is also Heather told about in the lecture during the E-Run 2018. So it's a data that is available on the Plackett Luce model, or Plackett Luce package. And then we are going to talk about getting the ordering of these rankings provided by the farmers. How can we change it into a sparse matrix, and how can we compare these, add the comparison of the local variety. And I will talk finally about the rank tricot, which is a function from the package GoSet that makes this process quite easy, so you don't need to do it every time. You just need to understand how the process works. So to set up this lecture, we need the packages Plackett Luce and the package GoSet. I recommend you to download both from GitHub, because by today both packages have important updates that are not available on CRAN yet. So let's move to the R environment. So here is my R project with the tricot analysis. You see, it's the same thing as the introduction to R lecture. So I opened just the tricot analysis R project, and now I'm going to work with everything here in this environment. So I will open this script called section 5 tricot into PL rank, and this is the elements for this, what we are going to do here. So first thing is I have put a comment here. So if you don't have downloaded yet the packages, you should have done it. So you just need to unlock these lines here, and run it. And once you have installed the packages, you block it again, so you don't need to run it again. It's just one time. In the first, then another thing that we do is load the packages. One good practice in working with R script is that the first thing that comes from the script is a short description of the script, what this means, and then you load right away the packages, all the packages that you need for the analysis. So you don't load another package on line 100, and then you see that you don't have the package, and then you have to run everything again from the beginning. So the best practice is to keep it in the first line, so this will be the first things that you run when you open the package. So, and then as I said in the comments, you can either run it here on this button, or you can click on Ctrl R. So I will do this in the way clicking on Ctrl R. So I will run the library, and also run GoSet, and it prints out some messages showing about the methods. And the first thing is that we talk is about the data called beans. Now it's the data that also Heather told in the introduction to Plackett Luce. So what we do here is using the function called data, and then we put it in brackets. We put in quotation note, we put the name of the data set, which is beans, and then we go to we said that it belongs to the package called Plackett Luce. So we run it, and then what it returns to us is like this beans, and then it says promise. So this means that the data is loading, so in some way it will be here. If we click here, we see the data set, the like variety A, variety B, variety C. So it's a very standard tricot way, which I expect you to be very familiar with. And for this kind of data, we just have the overall comparison. So what it means is that we have the 3 varieties that were assigned to each farmer, and then we have the best and worst regarding the overall appreciation, and then we have the comparison of the local, whether the variety A was better or worse than the local. So in the case of here, it says that variety A was worse than the local. It says that variety B was worse than local, and variety C was better. And we also have the season, we have the year, we have the maximum night temperature, we have the longitude and latitude, and we also have the planting date. We are going to talk more about these other variables in this data set in the next section on visualization and summary of the data. Here the focus is turning this into a ranking in the way that Heather showed in her lecture. To get to know more about about this data set, and also if you want to know more about some functions in R, one special hint is that you use this interrogation sign. So then you understand that you want to know more information about it, and for sure you are going to find it in the documentation. So for example, if we type interrogation beans and run it, it will turn to me the documentation that Heather wrote for this package, for this data set. So it says everything that I said before about the variables that it's available, and the details on the data set. And also here Heather has all the code that she used to convert the data set from tricot format into the Plackett Luce format. So if you just need to copy and paste it, and you are going to get it, but I want you to learn the process. So just few things is that the structure of the data is that it's that way. It's 842 observations and 14 variables, and it also is showed with this function called tim. I already showed in the introduction to R. And then with this function called head, we can take the first 6 rows of the data set. Let me put it a bit small here, and this one as well. So if I put head, it shows the first 6 rows of the data, and if I use the other function called tail, it will use this last 6 rows of the data. And you remember about the index that I was talking about. So then it shows here like the index for the rows, now 837 and 138. It means like for this last 6 rows, and then for the first one it has 1, 2, 3, 4, 5, 6. So first thing that I do here is select the variables that I need for this exercise. So the variables that I need for this exercise is variety A, variety B, C, best, worst, and the comparison of the local, which is variety A, B, and C. So I will create a vector called cell, which means for select. So I will call it cell, and I will assign this as with this command, arrow to the left, and then I press it. And remember that the function I told about the in. So now with this function I can check if I wrote the names of the functions correctly. So now I will check it here. For example, it will return for me the vector with true, which I expect should be all true. So then, for example, I can pass this to put it on the vector on this function called all, and then if all the elements that I wrote here are correct and match with the ones that are in the call names of beans, it will turn to me a true. So this is just a way to validate what I wrote. So for example, if I put here variety A, the answer here will be false, because I remember that R is a case sensitive language, so everything should be in the equal in the case, in the case of the letter. So should be A, and then it will return here. So this is to prevent any error in the upcoming moments of this training. So I will create a subset of the data, which is called beings2, and I will select only the 3 first rows of this data. I will select the row 1, 2, and 3, so from 1 to 3, and remember that I created this vector called cell, and this vector matches exactly with the names of the columns in beings, in the data frame beings. So what I can do here is, instead of writing all this thing again, I just need to pass this vector cell as the subset for the columns. So remember that I have the brackets here. I will write it again. So I'm creating a new object called beings2, and I put arrow to the left, and then beings, brackets, and then I put 1, 2, 3, and then I put cell, because this is the same thing. If I write this cell, it's the same thing that I am writing this, but this is it's bigger now, and then I already have this. So I just need to put here, and I will have this data set called beings2, which is with these variables, beings2, the ones that I need for this. So everything that I could do, of course I showed you, here Heather wrote this code. I could do this in R, and I prefer to do it in R because it's the way that you can replicate the analysis if you want to do it again. But here I'm going to show this, how this works manually. In Excel I will do this, so you understand the process rather than the code that I'm going to use it. So I prefer you to focus on the process rather than the code here. So what I'm going to do is I will export these beings to the disk, to my computer, and I will use this function called write.csv. Remember, that's why I don't really like to use dots, because dots belong to functions. So I will put write.csv, and I will do it again. Write.csv, and I put the name of the data frame that I want to write, beings2, and then I put file, which it will be the name of this file in the disk, on the disk. So I put bracket, quotation marks, and then I want to write it on the data, the folder, subfolder data. So I put data, and then I put slash, and then bin subset .csv. So I have to write the extension of it, so otherwise it will be just one file without the extension, and then the computer will not know what is it. And another thing is I will use these row names false, so it gives to me only this and not the row names. So I write it, and if I go to my folder, if I go here to my folder of the project, now I have the data, and then I can see the data that I created. So it shows exactly that was created today at this time, and then I can open it. And here's the file, and I will make it a bit larger. So all this process is documented in this slide, so you can also follow up with the slides that we have. But here I want to focus on the process. So the first thing that we do in the slides is getting the ordering. So this is very important. I want to know the ordering, which variety was the best, which one was the middle, and which one was the worst. Remember that in the tricot we only ask for the best and the worst, so the middle is implied, and I will show you how this is done. So let me create here one thing that called best, and which another one that is called middle, and the other one is the worst. So let's go by rows. Now, like in the row, this row here, the best variety was variety C. So then I copy here and I put it here. The worst was A, so I will copy it here and put it here. And since the best was this one and the worst was this one, so it is implied that variety B was the middle. It's not even better and not worse, but it's in between these two. So I will put it here. So I will do the same thing. The best variety for this second observation was B, so I will put it here as best. The worst variety was A, so I will put it here, the worst one. And it implies that variety C is the middle one. And then I will go for the third line, which is shows that this variety A was the best, and this variety C was the worst, and variety B was implied to be the second one, the middle one. So now I moved from a tricot ranking to an ordering matrix. Is an ordering matrix. So I have the order that this one is these varieties here are the best, these varieties here are the worst, and in the middle and these one are the worst for each of these lines. No, line 1, line 2, and line 3. So now I got the ordering. And with this ordering, Plackett Luce already understand it. And if I pass this through this to this function called as rankings, and I put the object here, no, the name of the object, doesn't matter the name, but with this characteristic, and I use this argument called input equal orderings, it will return for me the data, the Plackett Luce rankings in the way that we expect. But as I said, I want you to understand the process. So this is the ordering, but this doesn't have any sense yet. No, doesn't make any sense in terms of quantitative research. So then what we do is look for what we call a sparse matrix. A sparse matrix is a matrix which most of the elements are filled with zeros, no, and just few elements are the real, the valid numbers. And in that case, since we work with incomplete ranks of 3, so this is the best way to show the way that this data is stored in the computer. First, I will create one vector. It's the same thing in R. No, I will create one vector which is the name of all the varieties as columns. No, you come here. You don't need to really go through this. I just need the unique names here of this, and then I will transpose this. So then I have this now, but first I should have done put it in alphabetical order because it's easier to find it. So I will put A to Z, and then I will transpose it again. I will transpose here right away. So then I have the 1, 2, 3, 4, 5, 6, 7, 8 varieties in the transposed. So each column will be the name of the variety, and each row will be the observation by a given farmer. So what I do here, I will put the number. So remember that this is a ranking. No, actually is a ranking. So I will put it in from the order for 1 to 3 because I have 3 varieties in each row. So which means that the best variety will get the number 1, which is the first place in the ranking. The middle one will get the number 2, and the worst one will get number 3. So let's fill up this sparse matrix. For farmer 1, the best variety was PM2 Donray. So I will put number 1 here. The second one was the middle one was this SJC, so I will put number 2. And the worst one was BRT, so I will put number 3. So for the second farmer, Intra Centro-Sul was the best one, Intra Sequia was the second one, and Intra Rojo was the third one. And for the third farmer, Intra Ferroso was the best, Intra Matagalpa was the second, and BRT, Intra Ferroso was the best. You see, that's one of the problems of doing this manually, so you can make mistakes and sometimes you don't realize, and I'm really only working with 3 data. So I will erase it to start it again. So for line number 1, Intra Ferroso was the best, Intra Matagalpa was the second, and BRT was the worst, the third one. So now I just need to replace all the empty spaces with 0. So this is my sparse matrix. Now I went from this kind of data, like the tricot data, to actually a ranking data, a ranking with 3 elements, incomplete ranking. So you see that sometimes Intra Ferroso is not evaluated, but it's filled up with 0. If you read the paper by Heather and the collaborators about the Plackett Luce, one thing that she argues that one of the problems with this kind of matrix is that you are filling with zeros, and this has a computational cost. So if you are working with a big data file, like a very large data, it will have a computational cost, and this is something that we are going to work with in the future. But this is just a comment, just to talk about the zeros here. This has no implication if you are working with 1,000 data. What I mean here is more like millions of data. So this is the actual the rankings, and this is the sparse matrix that Plackett Luce uses to fit a Plackett Luce model. And if you look at here in the slides, I show the same process, from getting from the ordering to a sparse matrix. And even here I have one link for you to learn. If you want to learn more about sparse matrix, you can just click on it. And Plackett Luce has a fancy and a nice way to print this out, to show the output of this ranking. So this is not very useful to read. Now you see that it's very difficult to read these rankings. Imagine that you have 20 varieties and 100 and 1,000 lines. It will be very difficult to read it. So Heather created this printing method, which is this one. So instead of reading this as this way, you can read it like this way. But this here is the same thing as this here, but internally read it as this, but the computer understand that sometimes it's not easy for you to read it, so it prints for you a better human interpretable way to read it. So the better human interpretable way to read it is by this way. So you know that PM2 Donray is the best, is better than SJC, which is better than BRT. We know that Intra Centro-Sul is better than Intra Sequia, which is better than Intra Rojo. And we know that Intra Ferroso is better than Intra Matagalpa, which is better than BRT. So how can we do the comparison with the local? The comparison with the local is done in the pairwise comparisons. It's comparison in pairs. Instead of having a ranking of 3, we have a pairwise comparison, one against the other. So it's like a tournament, like when you have a match between two sport teams, no, one international versus Real Madrid or something like this. So it is a pairwise. It's a pair of items competing between each other. So we what we do when we compare with the local is that we don't put the comparison with the local in the same vector as the comparison with the tricot. Why we don't do this? Because this can sometimes one farmer can say that the variety B is better than the variety A, and in this variety is better than the local, but sometimes also the variety A can be worse than B. So this will change everything in the rankings, and will make a very confusing way to read the rankings, because these are two different questions in the tricot approach. So one way that Heather and we came out with a way to solve this is to put the comparison with the local as an additional rank. So you are going to have your rank with n farmers, so in our case 3 farmers, and then each comparison with the local will be added in the bottom of the matrix as n comparison. So if you have a comparison against 3, you are going to add 4 rows. No, you have four things. So you have a tricot comparison, and then the comparison between A and the local, comparison between B and the local, and comparison between C and the local. So you have 4 times the data, the length of the data. But this is not a way. This is not oversampling. It doesn't. You don't need to read it as oversampling. This is just a way to get rid of the reorder effect on the 3 varieties. By the end of internally, Plackett Luce will understand that this is an additional ranking, and will put it together in a single vector. Okay, so this is just a way to order the data, but it's not oversampling on the data. And I will show this in Excel. So let's do, for example, for variety A. And here we have a variety A, and here we have a question regarding if variety A is better or worse than the local. So the first thing is get the ordering. So let's say that this is a pairwise. So let's see that we want the best and the worst. And then the farmer said that the variety A was worse than the local. So here for the best we put local, and for the worst we put BRT. And also variety, the farmer 2 also said that his or her variety A was better than the local, so was worse than the local. So then we put local, and then we put the variety A that was assigned to this farmer. And then the farmer in this case said that the variety A was better than the local. So then here we put A, and here we put local. And here we have the ordering effect of the ordering of the ranking. Now we have the best and the worst, and then we just need to move to the sparse matrix, and then we have this here, and we add local here. So now instead of having 1, 2, 3, 4, 5, 6, 7, 8 items, 8 varieties, we have 9. And then we see best. So variety local was best for farmer 1, and BRT was the worst. So this takes number 1. Number 2, variety local was the best for this farmer, and Inta Matagalpa, Inta Rojo was the worst. And then Inta Ferroso was the best for this one, and the local was the second best. So then again we just need to fill up this with zeros, and we replace everything with zeros. And then we have the sparse matrix, which is added at the data. No? So we have the original one with the tricot, and then what R does is what the function does is just put the comparison of the local in the bottom of the data. So then instead of having a data with 842 farmers, we have a data with 3,368 rows, because it's the number of farmers plus 4, no, times 4. The original tricot plus the comparison against A, B, and C. But I hope that you understand this process, and I if you don't understand, please, maybe you can rewatch it from here, from this part, and try to see how the process works, because this is very important for you to understand. Now, how can we came out from the answers that the farmer gave to only 2 answers to a ranking of 3? So this is a very important step for you to understand, and I hope that you get the idea behind it. And so if you get the idea, you don't need to do this manually, or you don't need to write the code, because I already did it and had it. No, we wrote this function called rank tricot, which is a way to help you to avoid this kind of problems, or to avoid the trouble to write everything. So the function basically has 3 arguments, and a 4th one is the comparison against the local. So the 4th argument is the data, which is the name of the data set that you are working with. So this is the beans data, and then you put the items, which are the column names for the variety, the columns where the names of the varieties are. No, so we pass it as a vector with the names of the varieties: variety A, variety B, and variety C. And the input is the ranking that were provided by the farmer. No, the best and the worst. Which one is the best and which one is the worst? Remember that this should be in this order. Don't change the order. If you are going the order should always be. It doesn't really matter the name that you put here. If you want to call it variety first, variety second, and variety third, it doesn't really matter the name that you put here. What really matters is the order that you put in the vector here. No, so the first item in this vector should be always the A, and the other one should be always the B, and the third one should be always the C. So the order is very important, but not the name of this. And also here, the name doesn't really matter. You are going to see it in the next lectures, that the name doesn't really matter. What really matters is the order. The first one should be always the best, and the second one always the worst. I will copy this code here, and I will put it on our it's already here. So I will put it on my R code. So let's see here, for example, let's still work with the beans data to the beans 2. So first thing I just need to put is the data beans, and then the items variety A, B, and C, best and worst, and I will call it R. This is a very common way for me to call the Plackett Luce rankings. I prefer to just call with capital R. It's easy to write right away, so I don't need to write long things, and just need to run it, and this returns to me the Plackett Luce vector. And if I do something called unclass, the function called unclass, it will return to me the sparse matrix for rows 1, 2, 3. And also, if I do here the same thing for adding the local, the only difference that I use this argument called additional rank, and the additional rank is the data frame. This is not the vector. So remember that here I'm passing the vector, which should match exactly with the name of the columns in the data frame. And here also input should be the matching exactly with the names of the columns of the beans data. But the additional rank is a data frame. I'm passing the entire data frame to this. So here I have the data frame, which is with these answers, which should always be in this way: worse and better, right, written this way. And then I will run it, and I will have times 4 times 4 matrix, which is now is for 12 lines. And if I do on class, I will see this sparse matrix. And the same thing can be applied to the beans data, the entire beans data. Now I just need to write it here. Beans. So now I'm calling for the beans data, and they are basically the same as the beans 2. The only thing that the beans 2 is just a subset of it. But if I put it here, I will just also need to update here now, beans 2. And well, see, there is an error. I got this error, but I already know that the error is about, because it says number of items to replace is not multiple replacement. Is that not very informative message? But this means that the first element is bigger than the second one. So this one is bigger than the beans 2 that I was trying to pass. So now it will go, and I have this vector. This object, which is a object class, for example, is an object of class rankings. It's a Plackett Luce rankings. And also Heather also said in the lecture of hers that there is another object which is called grouped rankings, which is the one that we are going to use in the next lectures as well. So to do this, I call it G generally. And I just need to pass another argument which is called group, and I just need to say true. And this is different than R. For example, the R document, if I print R, for example, R, if I do head R, and I have this, but if I do head G, it will come with the index. So what this means is that R will look for the index on the local variety as well. So everything that it will match the index from the line 1 for the farmer 1 with the comparison of the local in the same farm. No, so that's why I'm saying that it's not oversampling. It's just a way to organize the data in a better way for not making confusion in the original rankings of the tricot. I hope you understand this lecture and that you train it. There is an exercise for you here, and I really look forward for the next section, which is showing some visualization and summary tools for the Plackett Luce rankings. Thank you.